Well, we're nearing the end of the year, and so what I thought I'd do for this video is a compilation of everything I posted in 2024, broken down into really short clips. I'll try to put a timestamp in the description, so if something catches your eye, you can go watch that video. And hey, if you would, leave a comment on a topic or a video that you'd like to see. I hope you had a great 2024, and I hope 2025 is even better. Let's get into it.
First up is a multi-pass T-joint on carbon steel with TIG. I did this video because of a comment I got on a YouTube video from a student who was really kind of struggling with this in school. And his instructor limited him to 140 amps or so. I think the instructor's reasoning was that's a pretty good all-around amperage that you would use on socket welds with 1/4 inch wall thickness. There were several more passes. I just figured I'd show the first one here. Up next, stick welding with a TIG torch. This one got posted over at welderskills.com. In a pinch, like if you forgot your stick stinger and just need to burn a rod, you can chuck it up in a TIG torch. All you need is the right size collet and collet body, and it'll work just fine. I learned this from a boss I had one time. I needed to weld a floor grate that had got bent, and it was kind of a trip hazard. And we didn't have a stinger. And he said, well, just use a TIG torch. And he explained it to me, and I went and had to burn like one 6011 rod, and it got me out of a jam. This is a 332-7018, a very useful rod. You can see that full video at welderskills.com. Next video, I compared ER70S-2 to S6 to ER309. In my opinion, for a fillet weld like this, there's not a tremendous amount of difference on good clean metal, but on an open root joint, there's quite a bit of difference between the S2 and the S6. This is a good video in general on TIG welding a T-joint on 11 gauge. If you do any work for machine shops, a very common repair is just to repair or put back metal on a miscut. Could be a chamfer that's on the wrong side, or a misdrilled hole, or a tool crash. But a really common repair is just to add back metal so that the machinist can remachine it to original dimension. Sometimes it's a really simple job like this, where all I had to do was run a couple of beads on top of one another. And for a job like this, my main concern would be to have a porosity-free weld so that when they machined it, it wouldn't show any holes or any dots. That video is also at welderskills.com. I did a video on dialing in a cleaning and weld procedure for a full penetration butt joint in the 40 thousandths thickness range. Anytime you're doing a full penetration aluminum butt joint on aluminum sheet, how you clean the backside is really important as far as that oxide layer goes. I built a wood heater for a friend out of some 20-inch pipe. I worked with my friend Matt Hayden on that project. He's one of our instructors over at Welder Skills. This is for a good friend of mine. He's going to put it in his workshop. Hadn't fired it up yet, but I think it's going to do a really good job. I've done several videos comparing AC frequency settings for TIG welding aluminum, and this is another one. This is 1/8 inch thickness 6061 aluminum, and I compared 60 Hertz to 250 Hertz. What you're seeing here is the 250 Hertz. And it worked really well. It's just a little bit hard to listen to. I had my good friend Andrew Carden over, and we shot a 2-inch Schedule 80 6G pipe test, TIG all the way. I'll just show a little bit of the last bead on the cap. If you got a 6G pipe test in your future like this that's TIG all the way, I think this will be a very helpful video. It's always a pleasure working with Andrew. Always fun too. This is a horizontal aluminum full penetration butt joint in around 050 thickness, using the settings that I dialed in from just doing a bead on plate in an earlier video. I use a number 5 clear cup on this one with a tapered 332 electrode. Normally I would probably use a 1/16 filler metal on something like this, but it turned out that the 332 helped me kind of keep that puddle full, and it actually kept me from having underfill on the backside. I built a TIG finger display because I was heading to a trade show. I got lots of nice clear arc shots on that with lots of outside corner joints, but then I also did a butt joint just for display, because I know that hanging this thing in any welding supply store, that welders are going to inspect the welds. And so I wanted to put one good looking bead front and center where everybody could see it, because as welders we all have to inspect welds, especially on carnival rides. A stick welding video that I posted at Welder Skills was 7018 1/8 rooftop overhead. That's where it's not like a upside down 2F, but sure enough overhead rooftop they call it. Got some good tight arc shots, listed all the settings. I really struggled a lot with overhead when I was in welding school. I've got a lot of scars to prove it. I even had to go shopping for cheaper clothes because I was just burning up my clothes. But once I discovered to hold a tight arc, things changed. I've done several videos testing different types of tungsten, and there are a lot of different types. So I tested on DC and on AC, and as expected, the DC, not much difference, but there was definitely a difference on AC. I've done a whole lot of testing, but for what I do, 2% lanthanated works really well for me. There's definitely other options. Here's an 11 gauge carbon steel T-joint, hot and fast. This is my friend Andrew Carden again doing this joint. Pumped the amperage up quite a bit on this, higher than I usually go. I think we're up around 160, but motoring out pretty good. And the results kind of hard to argue with. Part of the reason for the higher amperage is there's a double thickness on the bottom. 1/4 inch TIG welding aluminum using the PRIMEWELD 325. I use a number 5 clear cup. I showed the effect of using different angles, good clear arc shots, and of course a cut and etch test to verify penetration or lack of penetration. I'm going to be doing more stainless steel joints in 2025. This is a 1/4 inch lap joint on some scrap pieces that were laser cut. The thing about stainless steel is heat can build up really quickly, so you generally need less amperage, but you got to get in and get out. You got to get moving quickly and avoid that heat buildup. Another aluminum TIG project I did was another smaller version of that first TIG finger display. I used tread plate for this one, and it was slightly thinner material. Still got some really good arc shots, listed all the settings. It was a fun project, and I could definitely see this one sitting in local welding supply stores. I filmed a video on how to MIG weld better with short circuit MIG, and I discovered I never really posted that video, so you can look for that one pretty soon. Of course, I compared pushing to pulling, and of course we're going to get a lot of comments on that about how you should never do one or the other. But honestly, I've done a whole lot of testing on pushing versus pulling, and there's not that much difference as long as you don't get carried away with your angle. I also showed a good way to get some cheap practice by just padding beads on 11 gauge. A 332/7018 is one of the most useful rods that there is, and part of the reason is you can often run on 115 volt power. I've got it set here at 87 amps because 95 would have blown the breaker, but I was testing out the capability of the machine on a turntable. For thicker aluminum, I often move the torch ahead about 1/8 of an inch between dabs of filler wire. But for thinner aluminum, if you move ahead too far, you can blow a hole. When I first saw a clear cup at a FabTech, I was kind of skeptical. I didn't use them for years, but then when I first tried one, just trying to film a good arc, because I knew it would light everything up, I discovered really quickly it helps me see better. In addition to that 6G you saw earlier, I worked with Andrew on this 2G, 1/8 inch gap, 1/8 inch filler wire, TIG all the way. 100 amps was pretty good for a lay wire route. Bumped it up just a little bit for the hot pass. This joint was freehand all the way out, which would be probably the common method or common technique for a Boilermaker to use because they don't ever have room to walk the cup. The video shows all the passes all the way out to the cover pass. This is just the root and hot pass. A titanium T-joint, like you might take for an aerospace weld test, is tricky. If you've never welded titanium before, you might not realize how sticky it can be if you get the hot tip of that wire outside of the hot part of the puddle. This video shows a technique of going forward and back and then feeding the wire into the hottest part of the center of the puddle. That is what has worked for me. I did another video testing AC frequency settings using the PRIMEWELD 325, 150 Hz versus 250 Hz on the edge of a piece of 3/16 thick 6061. There were some minor differences, but not that much. I did a video showing some simple machine settings using the PRIMEWELD TIG 225. Using that same joint where I compared different filler metals, I just showed that simple DC settings are really simple even though there's a lot of knobs on the machine. A lot of the knobs there are for upslope and downslope and things like when you're using the torch switch with 4T. But if you just plug in a foot pedal, you can ignore all those knobs and it gets really simple, and it's the same with aluminum. All you need to worry about is AC frequency and AC balance. For those of you that are thinking about maybe getting into the aerospace industry, I made a video showing a practice joint using a very crude fixture with argon purging that I made 35 years ago. A lot of aerospace tests are in the 30 to 50 thousandths range. The thinner you go, the more likely you are to melt an end away, and the D17.1 gives you some leeway on that, but it sure is better not to melt the ends away at all. When you're learning how to TIG weld aluminum, even if you already can weld carbon steel or stainless, a very common problem on fillet welds like T-joints is just getting started on the wrong foot, using too long an arc, starting off too big, blobbing the metal in there because the arc plume is too big and it melts the tip of the wire, and you blob the metal in there instead of feed it, and you're not pushing that metal into the root of the joint. You're getting lack of fusion, you're getting that boomerang, that horseshoe effect, and that's not what you want. You want to start off better than that. You want to start off small so you can keep it small. A tapered tip helps, not completely necessary. Try to add the minimum filler to get the two pieces joined. Pause for a second or two. Let things melt together. That works much better. Arc length and torch angle are two of the really big things for TIG welding aluminum. I did a spool gun video on 1/4 inch lap joint using the spool gun that came with the MIG 180 PRIMEWELD machine. You want to use a push angle whenever you can with a spool gun. That helps keep the puddle clean and soot free. A little soot happens every now and then. It's not the end of the world. It usually wire brushes off, but you don't want it. I did a back to basics 7018 stick welding video. It doesn't get much more basic than padding beads. Padding beads is one of the first things you do in welding school after you learn how to run a bead or two. Next thing to do is stack them on top of one another and try to go halfway over top of the previous bead. And sometimes it helps to use just a little bit of motion to help the bead flatten out. No matter if you're padding beads or doing a T-joint in flat, horizontal, overhead position, a good tip is to set the amperage hot enough where the rod won't stick when you hold a tight arc, then hold a tight arc. I'm not talking about jamming it in there, just a tight arc. There's a lot of overlap in the diameter of tungsten that will do a certain job. In this video I compared 1/8 to 040. This was only 16 gauge stainless, so I certainly didn't need to use a 1/8 diameter tungsten, but I compared it to an 040 and the results were very surprising. You would think that the 040 electrode would make a smaller weld at the same amperage as the 1/8, but again, the results were very surprising. I did another back to basics 7018 video, just stacking 3 beads on a T-joint, a multipass T-joint on 11 gauge. It didn't need 3 passes, but this is just a practice joint when you want to get the most out of your metal when you're practicing. So I showed the importance of the stick rod angle. Rod angle can be very forgiving, but if you want to get the best results, you use a different angle for each 3 of these passes. As always, a good tight arc helps, and actually the rod angle is a lot more forgiving if you're holding a nice tight arc, but using this angle on that last bead helps to prevent undercut. I did a video with 7 tips for TIG welding aluminum, and here's one quick tip right here. Aluminum tack welds can be really weak, and when you heat them up they get really weak. So instead of lighting up on that tack, I made an additional tack and then backed into my tack and then welded over top of that extra tack. And it helps to keep a tack from popping loose where you might lose your fit up and have to weld a gap or have to stop and re-tack it. 6 more tips in this video, that's just one of them. 5F TIG carbon steel. That's a tube to plate type joint. I compared walking the cup to propping and freehanding with a TIG finger on this video. A 5F test is not all that common, but it is used sometimes to qualify a welder for socket welds and other fillet welds. Sometimes there might be a need to make 1 or 2 welds, and that's the only socket welds you have to make, and you're not qualified on a certain diameter or whatever, and it's easier to send you to do a 5F test than it is a full-blown 6G test, and that's when they might use a 5F fillet weld test like this, tube to plate. I did a silicon bronze video called Gold-Plated Horseshoe, and I showed some pulse settings that I learned from doing these lap practice joints, and I used those same pulse settings in a previous video making this Thor hammer years ago, and those same settings work to overlay silicon bronze on this horseshoe. My idea was, because of that old saying about, if somebody's lucky, they must have a horseshoe up their butt, my idea was to put a lot of silicon bronze on there and then polish it where it looked like it was gold plated. I did an aerospace weld test T-joint video, just a practice joint. This was just using 304 stainless steel. You would rarely do that particular alloy for aerospace. It would usually be 17-7, 15-7, 17-4. But 304 is easier to get, it's cheaper, and it's good practice leading up to something like 17-7. The Furic MK14 was a great cup for this joint. And you can see there's almost no discoloration. I did a fillet weld on a turntable using the PRIMEWELD 325. I talked a little bit about dialing in AC balance cleaning action. I was using a number 7 clear cup with a tapered tip using a 1/8 2% lanthanated electrode. And I was up around 220 something amps to start, and of course as the piece heated up that dropped a little bit. From the arc shot, it didn't really look like it was punching into the root that well. I like to test welds using the cut and etch method just to show me if I'm right or wrong. This one was a little uneven, but it got in there. A technique that's used pretty frequently in aerospace and other sheet metal type work is backstepping. And when you're backstepping, you're welding to the previous weld, but you need to know how to taper off slowly. And one of the best ways I've found is to keep the torch traveling as you taper off amperage slowly to kind of make a sort of a comet trail. And that really helps on crack sensitive alloys. This little shot of Andrew making an outside corner joint shows just how well a number 7 clear cup can light things up. Once again, I started using clear cups just strictly to film because I knew it would give me a better arc shot, and if everybody can see the details better, everybody can learn more. But I learned really quickly that not only do they help me film a better arc, but they help me see the arc better, and they help me see where I'm going better. I still use ceramic cups a lot. I don't always need a clear cup. You may not need one either. Maybe your eyes are perfect, but they sure do help me see. Now, here's just a few clips of some previous videos that I've done over the years using clear cups. Lap joints on 11 gauge steel. This is 1/4 inch thick using an advanced pulse where the arc alternates between electrode negative and AC. This is some square tubing just using the lay wire technique. I like to experiment with pulse settings on different projects. I've done a lot of side work over the years, and most of the time I could do the job without pulse, but there were a handful of jobs where pulse really helped. This was a fun little project, just welding some end caps onto some pipe. I wasn't trying to get full penetration. In fact, I was trying not to get full penetration. You'll see part 2 of this project in 2025. I've got some little giveaway items I'm going to make out of these things when I'm finished. A lot of people have guessed minions, but nope. Good guess though. If you have to weld aluminum out of position and there's no place to prop, a TIG finger can really get you out of a jam. Sometimes there is no place to conveniently prop, and with a TIG finger on your finger, you can prop right next to the weld, and you'll be thinking about the weld instead of how hot your knuckles are getting. Something we've all seen a lot of lately on social media is laser welding, handheld laser welding especially. I got the word that there would be a laser demo at a local welding supply, so I decided to go there and film some clips. And so I welded a lap joint myself, but then compared that kind of to the speed of a fillet weld using the handheld laser. Another thing a laser is capable of doing is cleaning rust and mill scale and stuff like that off odd-shaped parts. Discoloration on stainless steel is just something that usually you just kind of wire brush off and that's good enough. But there are certain industries and certain applications where that's not good enough, and you need more corrosion resistance than that offers. And when that's the case, electropolishing and passivation is needed to restore corrosion resistance to the surface of a welded joint. I got my hands on an easy clean electropolishing unit and did a video on how easy it is to remove discoloration from several different types of stainless welds. It's always good to go back to basics. This video is on TIG tips for beginners and really concentrating on the importance of arc length. TIG welding is no different than other processes in that padding beads is some of the best practice you can get when you're a beginner, because you don't have to do much preparation. It doesn't require much metal, but you do need to pay attention to arc length. And a good rule of thumb is try to keep your arc length equal to or slightly less than your electrode diameter. There are a lot of skeptics out there when it comes to handheld laser welding, but it is so much faster for certain applications. But is it strong? Is it penetrating, or is it just laying up there like a caterpillar caulk bead? That's a big question everybody has. So I did a macro etch test on this weld, a cut and etch test. After a little polish and a little easy off oven cleaner for etch, you can see that it did get penetration, quite a bit of penetration. I contacted a non-profit called REIGNITE Hope that offers welding training free of charge to people who have lost hope. This is a test that they use. It's an open butt, uphill, 3G position, open root 11 gauge thickness, single pass weld. It's a tricky little weld. Not much room for error. Gun angle and stick out are two really important things, as well as, of course, voltage and wire feed speed settings. But I kind of got it dialed in. If you need to make a full penetration weld on thin wall aluminum tubing, here's a tip for you. Number one, pulse settings help, but they're not enough. 2 pulses a second helped to kind of limit the heat wandering here, but wrapping that piece of copper braided wire around for a heat sink really helped get even, consistent penetration. It's mind-boggling just how fast handheld laser welding can be. This is 16 gauge stainless. I did a video showing kind of my best effort on travel speed on this same joint using TIG welding, but I was nowhere near as fast as this laser's doing. Hardly any discoloration too, which is kind of a big deal. A very useful skill to have that can make you a lot more marketable and keep you working is being able to weld sanitary stainless. It's usually done without any filler metal. Another word for that is it's welded autogenously. A lot of sanitary tubing has a wall thickness that's only about 1/16 of an inch, and so you don't really need filler metal. So a lot of it is done without filler metal, and there's a benefit to that because you don't risk introducing any oxide islands in there that you might get from the tip of the filler rod. It's all about the purge. It's all about the quality of the inside of the weld. There's a weld that hasn't been purged, and that's called sugaring, also called granulation. That'll trap bacteria. That's no good for food service. Got to have a good silver purge. A video that I would have loved to have seen when I was first learning to weld in welding school was just showing me all the different processes and a lot of different applications, all the different alloys that you could weld with TIG. I would have loved to have known the differences and the limitations of short arc MIG and spray transfer and pulse spray, and I did a video showing all of that this year. Short circuit spray and pulse spray all have their different applications, and I would have loved to have known that before I started learning welding. I would have loved to have learn the difference between a 6010 and a 7018 before I got too far along the way in my learning. I think that would have helped me a lot. I also would have liked to learn about self-shielded flux core, what the limitations were on that, and how important it was to have the correct polarity. When I was first starting school, I had no idea what dual shield was. Pulse settings confuse a lot of people. Like, where do you start? Where do you begin on a certain application? Do you use high-speed pulse, 1 pulse a second, 50 pulses a second? What works for what? So I did this video showing about a dozen different applications, showing how pulse can be used while you're training to teach you how to feed rod with rhythm, but then also different techniques like lay wire using pulse settings on an outside corner joint, and a whole lot more. Ever heard of super missile rod? Some people say it's nothing but 312 stainless. I don't think that's necessarily true. 312 is a very useful rod, but super missile rod is a very crack resistant, high chromium, high nickel stainless alloy that can be used to weld lots of things like dissimilar metals or cladding or high carbon steel, provided there's preheat. But 312 stainless is also a very useful rod. A joint that you might do in school is a vertical T-joint. This is kind of like the very first clip that I showed in this video, except that I walked the cup on half of this and free-handed with a TIG finger on the other half. A multi-pass fillet weld like this can be used to kind of train your eye and train your motor skills in preparation for learning how to weld socket welds. A lot of times you don't ever weld a socket weld until you get out in the field and you're just kind of thrown to the wolves. And this can help you be more ready for that. Different tungsten angles can have a different effect on the arc. This video talks about that. Also talks about how you can use 2% thoriated for aluminum, and there's a trick to help it work better. And that trick basically involves putting a taper on the electrode like you would for steel, and then slightly rounding the tip using the AC balance setting. If all you have is 2% thoriated and you need to weld some aluminum, putting a taper on it and slightly rounding the tip can help. It also helps to have several different grinds for different applications. Sometimes you really need to limit heat input, and even sometimes you might need to limit your penetration. Like if you can't get a purge on the backside of a stainless outside corner joint, maybe you don't want to penetrate, or maybe you do, but pulse settings can help you do either one. By setting a really low background current, you can limit your discoloration and you can limit your penetration.
Well, if you're still with me after a video that long, that means that you're really focused, you're really engaged, and you're trying to get better. So listen, take advantage of the 7-day free trial offer, link in the description, welderskills.com. For 7 days, you'll have complete access to all the courses, all the new videos in there, over 800 videos, stick welding course, TIG welding course. There's some mini courses in there for MIG and short circuit MIG, as well as pulse spray. Just a ton of resources, free for 7 days. After that, it's $12.99 a month. Cancel anytime. Stay 1 month, get all you can. Stay 2 months, get all you can. We're not trying to trick anybody into forgetting and letting it go for months and months and months. We also have a yearly subscription, but 7-day trial. For 7 days, you can see what's in there. I'm hoping you'll stick around, learn, and get better with the rest of us. All right? Link in the description. See you next time.